Hello, I'm Dr. David Kordowitz and welcome to Computer Programming. Today we're going to be talking about the use of variables and how to perform basic mathematical operations. Let's begin. Today we're going to start with a blank sketch and work our way through how to create variables and how to perform basic mathematical operations. The first thing we need to talk about is how to create a variable. Variables in the C and C++ languages must be what we call declared. In other words, you have to actually create the variable to be able to use it. This is not exactly the same way things work in MATLAB, but we'll discuss that when we get to the MATLAB section of this course. Variables need to be declared in C, which means that we have to tell the computer that we want a variable so that it creates that variable for us to use. Variables you can think about like a box that you can put things in. Remember, we talked about data types and we said that there are many different data types you can use. So for example, integer or character or floating point or double or boolean were kind of the big ones. But what we need to do is we need to actually give those boxes names so that we can store information in them. Variables in C have a property called scope. What scope means is that a variable, when it's within scope, exists, and when it's out of scope, it does not exist. Scope is defined by the innermost set of curly braces around your code. So, for example, in the code we have up here, if I declare something in setup, you simply type the variable type and what you want to call it. Now, if you notice, the innermost set of curly braces is the one around the setup function. This means that if we wanted to use the variable in the loop, it'll be gone. That's because it fell out of scope when it crossed into the loop. If we want it to be available in both, we can use what we call a global variable. To create a global variable, we simply put the variable outside of all scope. So we put it, say, up top, and the entire program is the innermost curly braces. The catch is with global variables that they are available to every piece of your program, and if they get modified in multiple places, you can never really keep track of who's doing what. For this reason, global variables are generally considered to be a sort of taboo when you're using programming. So a lot of times programmers will try to find ways of using scope to their advantage to move things around. On Arduino, it's a little more common to use global variables than it is in other programming languages and other applications of C and C++. That said, we need to be able to put stuff in our variables. So to do this, we can say something like my variable equals 2, semicolon. And what that's going to do is that's going to set the value of my variable equal to 2. In C and MATLAB alike, the element on the left is where you want to store something, and the element on the right is where it's coming from. So in this case, we're just using the number 2. Now, if we wanted to use another variable, we could. And you can say something like my variable equals my variable plus 1. Now, this would be invalid in this syntax simply because we haven't set my variable to be equal to anything quite yet. When variables are declared, you get a bunch of garbage in those variables. So using a variable without first what we call initializing it is not very good. So I can say my variable equals 2, and now this would make sense because my variable gets set to 1 or gets set to 2 here, and then it becomes 3 here. We can, again, because the variable is global, take this statement and move it down to the loop. So within this loop now, every time this loop goes around, that variable is going to get bigger. For the purposes of demonstration, let's go ahead and create a serial monitor as was described in the previous video. So now this program, when loaded on hardware, will print the value of my variable every time we go around the loop. I've gone ahead and started the upload to hardware. And now if we open our serial monitor, you'll see it just simply counts off numbers. This is what we would expect given this particular program. So let's take a moment to look at the Arduino reference to discuss sort of some of the mathematical operations we can perform. There are many of them. Some of them are quite basic and some of them are fairly advanced. So let's start down at the bottom. We have the ability to do what we call multiply, add, subtract, divide. We also have this thing that's the percent sign which says remainder. It's also known in C as modulo, and actually all programming it's known as modulo. And what this is if you divide two numbers by each other, what is the remainder? You could think back to elementary school when you first learned how to divide and you sort of counted through and then you were left with, something like R3, R4, whatever. That's what this does, is this gives you what that R value is. So a little more mathematics are available for you. A little more advanced mathematics is available for you. And in that case, we have absolute value. We have constrain, which allows you to constrain a variable within a range. Map allows you to take a variable that's in one scale and map it to another scale. This is really useful if you have, say, a thermometer that's giving you the temperature in volts and you know what the conversion formula is to get it to, say, degrees Celsius. You can use the map so then you don't have to worry about figuring the math out yourself. Max will give you the largest value of something. Min will give you the smallest value of something. Pow is power. SQ is square. And SQRT is square root. That said, most frequently I will use the power command and not the square command. So the power command comes in really useful if you want to square things or cube things or anything like that. In addition, we have available cosine, sine, and tangent. Now, there are additional mathematical operations available in the math.h library, which is given to you by C into Arduino. That said, this library is not documented in the Arduino software or the Arduino reference. That's because it is coming straight from C. If you want to know how this library works, you can go simply to cplus.com, and that's cplus.com. And once you get to cplus.com, go to the C library option down in the second box on the left, and then on the left here, find either cmath or math.h, and this will give you a list of all the functions that are contained within math.h. If you would like to use math.h, all you need to do is include it. To include a library such as math.h, simply go at the top of your program and do pound, which is what we call our number sign, include, and then in triangular brackets put math.h. By doing that, the cmath library is now available to us, so we can do things in C mathematics. So let's take something, for example. Let's try with a floating point number. So we're going to go and make it double. And we're going to call it my float. Now, it's a double, so which means we have floating point precision. Now that we've created the my float variable, let's go ahead and set it equal to something. So we're going to use the my float to do some trigonometric calculations. So in this case, what we're going to do is we're going to start by getting rid of the math.h library here because we're going to use the built-in cosine and sine functions. We're now going to go ahead and use something called a pound define. This is very common in Arduino and may also be common in standard C depending on what you're working on. So pound define allows us to give a name to something. So I'm going to say pi is 3.141592. So what this is going to do is this is going to define the term pi or pi to 3.141592, which allows us to use that as if it's a constant that exists. By using pound define, we're setting pi equal to this and it is unchangeable. This is useful for constants such as pi or e or things like that. So now let's take a look at what we can do. So we can say that my float is equal to sine of pi over 2, for example. If we go ahead now and compile this and send it off to hardware, we're expecting that our value should be very close to 1. And once we hit our serial monitor, we have exactly 1. So let's say now we want to look at pi over 4. So we can change that to pi over 4. And this is going to be a fractional number. And if we give it a second to compile, we can now see that it's 0.71. We know this to be 0.707. So 0.71 is good if you're rounding to 2 decimal places. So you can create variables and you can use basic mathematical operations here to be able to do calculations starting really basically, but you can combine these different mathematical principles to create larger equations and solve larger problems. I'd like to thank you for your time today and see you next time.